Now we know where the clutch goes in the vehicle and we know what its purpose is. Let's see how the clutch actually goes about transferring that power from the engine to the transmission. We're going to be looking at the easy pedal clutch from Spicer today. But before we actually get into the clutch itself, let's look at another important component in the assembly, the clutch brake. The clutch brake is located between the transmission bearing cap and the clutch release bearing. It is activated by fully depressing the clutch pedal in the truck. The purpose of the clutch brake is so that you can actually shift the vehicle from neutral to first gear or reverse without grinding the gears. It only is activated when the vehicle is not moving. So those people who are shifting all the way up and down the road, pushing the pedal all the way to the floor, they're actually defeating the purpose of the clutch brake. The next component we should look at is actually the cover assembly itself. The cover assembly itself is made up of a bearing and a retainer which holds the bearing in place. And this is also still part of that bearing retainer mechanism right here. The input shaft of the transmission passes through the center of this bearing right here in the bearing retainer. Inside the bearing retainer, at the bearing end, is a bushing. The bushing centers the input shaft of the transmission in the bearing. The next component of the cover assembly we'll look at are the springs. Within the cover assembly, there are actually three different types of springs. There are the angle pressure springs, the assist springs, and the return springs. The angle pressure springs are the springs that give us our clamping force or plate load when the clutch is engaged. They are connected to the cover assembly and then again to the bearing retainer. The assist springs are also connected to the cover assembly and to the bearing retainer, but they do something slightly different. They are used to help push back on the bearing retainer when the clutch is being disengaged. The third type of spring which makes up the cover assembly is the return springs. There are 4 return springs, and the purpose of these return springs is to help disengage the clutch when the clutch pedal is pushed down in the cab. As the clutch pedal is pushed down and the bearing and bearing retainer assembly is pulled back towards the transmission, these return springs actually help pull back on the pressure plate, which then allows a slight amount of separation between the driving member and the driven members inside the clutch assembly. Let's look at the levers. The clutch assembly itself is made up of 6 levers. These levers actually pivot between the adjusting ring and the retainer. As our angle pressure springs give us downward force, or that plate load that we talked about, these levers push on the back of our pressure plate downward force. This downward force actually will then be the clamping force to connect the flow of power from the engine to the transmission. The adjusting ring allows us to compensate for wear of the internal clutch components, the pressure plate, the driven disc, and the intermediate plate. As those components wear, the release bearing and the retainer travel closer to the engine. To reestablish our proper dimensions for release bearing travel, it is necessary to rotate the adjusting ring. By rotating the adjusting ring, the bearing now is repositioned closer to the transmission. When the bearing is in the proper position, the clutch brake will work. Now let's look at the pressure plate. The pressure plate is the final member of the cover assembly. The pressure plate is the member of the cover assembly that actually pinches the driven disc to transfer the flow of power from the engine into the transmission. The driven disc assemblies. Spicer offers 2 different friction materials on driven discs. They offer the ceramic and they offer the organic facing materials. The ceramic facing materials are the preferred material since they offer you long life. The dampener sections in the center of the hub provide an absorption capacity to dampen the vibration characteristics of the engine and keep them out of the rest of the transmission and powertrain assembly. The intermediate plate is designed to separate your two driven discs. The intermediate plate is part of the driving member and is driven from the flywheel through drive pins, which we'll look at later when we go to the shop, through these slots. And last, we have the flywheel. The flywheel is a component and a function of the engine. It is bolted to the engine crankshaft, and the flywheel is a driving member and spins whenever the engine is running. Driving members, flywheel, intermediate plate, and cover assembly, which does include the pressure plate, driven members, the driven discs, which then drive the input shaft of the transmission. Now let's go to the shop and see how all this works. Before we see what's happening inside the clutch itself, let's see what else is happening in our system, particularly with the linkage and the pedal. Remember that the clutch pedal and the linkage are part of the vehicle. Therefore, before making any modifications to either one of those components, make sure that particular vehicle manufacturer's guidelines have been consulted. As we push down on the pedal, the release bearing is pulled back. I'll demonstrate this for you, and you'll notice it doesn't move very far. What we are doing is we are overcoming the downward force of the pressure springs at this point. Those are the angle pressure springs that we spoke about earlier today. The mechanical advantage of the linkage allows us to overcome this plate load. You'll notice that the bearing itself is not moving very far, but it is enough to interrupt that flow of power from the engine to the transmission so that we can actually get that vehicle into gear or change a gear on an upshift or in a downshift situation. Why don't we go over and actually see what's happening inside the clutch. When we push down on the clutch pedal to release the clutch, the bearing comes back. As the bearing comes back to disengage the clutch assembly, the driven disc spin at the same rate as the transmission input shaft is spinning, while the driving member, the cover assembly and the flywheel and the intermediate plate now spin at the same rate as the engine. Let's take a closer look. The release fork pulls the release bearing and retainer assembly toward the transmission. This overcomes the downward force of the angle pressure springs. The assist springs help push the bearing retainer toward the transmission. The levers, which ride in grooves in the bearing retainer, also move toward the transmission. The pressure plate is pulled toward the cover assembly by the return springs. When the clutch is adjusted properly, this plate will move approximately 60 thousandths of an inch. When the pressure plate moves, the driven discs and the intermediate plate separate. Now that we've shifted the transmission and are ready to re-engage the clutch, we lift on the pedal in the cab, causing the release bearing to move forward against the engine. When this happens, all the components are pinched together, causing all the components now to rotate at a constant speed. Let's take a closer look. The release bearing and retainer assembly move toward the engine. The pressure springs exert a downward force on the bearing retainer. This forces the levers toward the engine. The levers move the pressure plate. The pressure plate pinches the driven discs and the intermediate plate together toward the flywheel. All the components now pinched together will move at a common speed. So that's how the Spicer Easy pedal clutch works. You know, we've been at it for quite some time now. Why don't we take about a 5-minute break, meet back in the classroom, and I'll answer any questions that you might have.